All right, here we go. Part 2 is using the equations, okay? Now, this is where the skills from your do now are going to come into play. Can you evaluate? If you struggled a little bit with the last one, please make sure you're paying full attention to this one, okay? Because there's a little more steps than tables and graphs. You actually have to calculate, all right? All right, so we're on the one that says part 2. So for part 2, there are a couple options on how to evaluate. First one that we're going to go through is option A, which is where you're evaluating the inner function, and then you're finding that output and plugging it into the outer function. Then we're going to do an example where you're creating just a whole new function, and then you're plugging in your values, okay? So we're going to go through both models and see which one you find most beneficial. Sometimes the other one is required over the other one, and that is okay. All right, so we're going to look at a completed example using our graphic organizer, okay? So here it says, what is the value of the expression g composed of f of 2? Given the inner function is f of x equals 3x minus 5, and the outer function is x squared plus 2, okay? So now you have values for your g of x, not just graphs and tables, but you have whole equations that represent g of x and f of x. Right here, it says that we have g composed of f of 2. So our inside is f of 2. Do we see that? Mm-hmm. Okay, on your do now, when you were given a variable of a number, what did you do? You plugged it in. So guess what we're going to do here? We're going to plug it in. So if it says f of 2, my first input is going to be 2. Everywhere there's an x, I'm going to put a 2 in f of x. So that gave me 3 times 2, which is 6, and 6 minus 5 is 1. So my first output is 1. This is what I'm going to put into the second. So what's the outside function? G. And G is x squared plus 2. For wherever there's an x, I'm plugging in a 1. That gives me 1 squared plus 2, which is just 1 plus 2, which is 3. So my final output would be 3.
Wait, so that's the answer.
That's the answer.
Wait, okay, I gotta go.
Yes.
For G.
How did you get 2 for G?
Yes, ma'am.
I didn't get 2 for G.
Like
I got f of 2 and I plugged in that and I got 1. And then I plugged 1 into G of x.
oh, okay,
Yeah.
okay.
All right.
So okay.
Now we're going to do a fill in the blank one, and then we're going to completely get rid of the graphic organizer, okay? We're going to take baby steps to understanding. All right, here we go. All right. So here we have the same, but this time it says G is composed of f of 5. Do we see that? And we're working with 3x minus 5 and x squared plus 2 still. What is our inside? F of 5. So that means I'm going to have to evaluate f of 5. So I'm plugging 5, right, James? I'm plugging 5 into f. So I'm going to take my first input is x equals 5. Where there is an x, it now becomes a 5. 3 times 5 is 15. 15 minus 5 is 10. Yes? Okay, so my first output is 10, and now I'm going to take that value and plug it into the outside function. What was my outside function? G. And what does G equal? X squared plus 2. So now the 10 becomes the x, exactly. So where x is, I'm now plugging in a 10. And what is 10 squared? 100. What's 100 plus 2?
102.
So my final output is 102.
Okay, I wasn't sure if I did it right.
Huh? Okay.
Let's say it was parentheses 3, parentheses 5, I think which the
Yeah.
So when we do x squared plus 2, then we do 5 squared and that.
Yes. You start with the G then.
That's not.
All right. Doable, right? All right. Now we're going to get rid of the graphic organizer and we're going to work it from scratch without graphic organizer. So flip over. All right, so notice here is written in formal notation, G composed of F at -3. All that this is saying, when I'm written in formal notation, G composed of F at -3, it's still telling me F is my inside, G is my outside. This is the same thing as GF of -3. Okay? It's my inside and then my outside. So from here, you're reading, I'm going to plug this in, then I'm going to plug that in. Okay? So step one, we're going to do the inside. What is our inside? F of -3. Do we see that? So I'm taking -3 and I'm plugging into this equation. Yes? So that gives me -3 minus 5. What is -3 minus 5? -8. So step two is I'm going to take the output from here and plug it into G, because that's my outside. So I have G of -8. So I'm taking -8 and I'm plugging into the G function. Yes? So that gives me -8 squared, which equals positive 64. So my final output is
64.
64.
Okay, that's not hard.
Yes?
That's good.
Okay? No, yes? If we're on the fence, where are you stuck at? So we can cross over. Really? All right.
So the
So-
bottom one is backwards, right?
So here's yours. So you're doing the bottom.
Like the bottom one is like flipped, right?
This time you're
Starting with F.
G.
We'll start with
You
G.
start with G. So your same function, but what does your composition say? F is composed of G. So where are we starting at? G.
So
Okay.
if we
I
come
don't
up,
understand like any of it. Like I'm copying what you're doing,
Let's
But-
copy.
I'm not understanding.
Okay, what's up?
I don't understand any of it. Zero.
So do you understand how to evaluate functions? Did you do your do now?
Yeah.
Okay, so you can do your do now, so you
Yeah.
can evaluate. That's all you're doing. Is you're evaluating F of -3. When you saw F of -3 on your do now, what did you do?
I forgot what I did. Multiplied it. No, you went to the G or the
You go to the
X.
function and
Yeah.
plug in.
Yeah, I did that.
That's what you're doing. So I'm finding F of -3. F of -3 means wherever X is in that function, it becomes a -3.
Okay. It's just the whole F working X thing is
But
throwing
that's-
me off.
That's what your do now was. The do now was literally just.
Yeah, I know, but
evaluate.
it's throwing me off. Like I understand the whole like,
It shouldn't have been. You should have did G first.
like I understand this thing, like down from like one to the next. so
No, you
like,
did F first.
And then like this thing, I don't understand like at all.
That's what I'm.
And then this thing, I'm like.
So this is telling me that you didn't understand your do now, or that you probably didn't do your do now.
I did like it down.
Okay, are you sure?
Yeah,
But-
probably wrong.
I am tired.
Okay. This is
It
just
was kind of hard to
evaluating
understand,
function,
all the tired.
plugging in for X.
Yeah,
Algebra 101.
this is
Yeah.
like probably one. of the
What
first
you
lessons
get
I
from your
had
first
to-
plug-in, you're going to take and plug into the second function.
but it's just the whole like, putting this one and this one, and putting this one in the exact spot that it should go in.
But
It's
that's
like, I don't know exactly where. I don't know how
Where
different-
X is, that's what it's replacing, it's a sub.
Yeah, but then you just said you gotta put the 8 where the G
It's like if
is.
you're playing sport, and I'm subbing you in, you're gonna go where that person was, right?
Yeah,
Same thing with a number.
are you
I'm
yelling at me?
subbing you in, no, I'm making it very clear. But push it through, 'cause
Yeah.
you're just subbing it in, that's it, it's a substitute.
Okay, yeah.
Wherever X is, I'm gonna put this on, tag you in.
So this X is -3? I get it.
Yes, so but this time you're substituting it into G first, and then what you get, you're gonna plug into the F.
Oh, okay. Okay, I'm gonna try it.
Wait, no, it's what when he closest to the number. Yes, that is first, so see how when we rewrote it, what's our inside? F of -3, remember it's the inside, then the outside, your poorly made joke that made no sense to nobody.
You're leaving a birthday. I'm staying back in it. The receptionist is called to get this stuff and tell me like, so this one right here. It's saying that. Because it's first. So we're gonna do that. Well, of course, I'm gonna do it. Everyone is supposed to put the number in. And,
That's how what I'm gonna do.
you didn't plug it out.
Yeah, I did, that's what I said.
You kept your X's.
Cause
You don't keep the X, you're sub.
So the X is
So
negative
I'm
three.
going back to call and I say sub in.
Is the
you're
first
still-
one one of eight?
No, the X is a negative three,
The X becomes the negative.
but you said the G is the negative three.
The X, there's G, sweetie, this is the function. This is the X that you change.
But you said change G,
Change G function, this is the G
so
function.
that's negative three, that's negative
This
three, and
is
that's
G
negative three.
of -3. So when I go to G, what used to be in parentheses,
An X.
what's now in parentheses.
Negative three.
So I'm gonna replace all the X's with a -3,
Oh.
and now I have my first output.
How do you know that that's nine though?
Because -3 squared is 9.
Yeah. Okay. Yeah, I get it.
Gray one, and you got one.
I get it. I just thought you said like, but negative three
That
is G.
I wanna see your email.
It's probably a joke, it's probably all wrong.
Oh, goodness.
So G of 1,247,000.
No, it's G. G is X squared.
Okay.
Give me a second, let me go over that.
All right, guys. Let's talk about this. So this time it's F composed of G at -3. So my inside is G of -3. Do we see that? So you're gonna do your inside first. So step 1 is your inside, G of -3. This is just like your do now. If I have a number and I'm substituting in for X, it literally is taking the place of X in that problem. So it becomes -3 squared. And what is -3 squared? 9. That's my first output. Now I'm going to take my first output and plug it into my outside function. What is my outside function? My outside function is F. So I'm going to take F of 9. So going to function F, wherever there's an X, I'm plugging in a 9. So we now have 9 minus 5, which equals 4. So you should have gotten 4. Yeah, you have one final output. You only have one final output. Okay? Yes, no, maybe so.
I think that if you just had the F from the B from the -3 from the it's like if you're following the dot, you do -3 first.
You do in their most parentheses first. Yes.
Wait, so the answer is whichever one we end on?
Good. Huh?
The answer is whichever one we end
Your
on?
very final output.
Oh, wait, you have to do two?
There's 2 steps.
I did one.
Then you gotta do the next one.
You can't do D first.
Did that one first.
Yeah, and then I left you to do the rest because you said you got it.
Nothing was anymore.
You said you got it. That's why I left you. All right. We will come back and I will walk around more when we get to the exit ticket. But we're going to do this last example together. All right. So yes, you probably did it the other way. What we're gonna do here is sometimes, really quick, guys. Sometimes when you have the same composition happening, it may ask you to create a whole new equation so that you can evaluate from there. So notice here that these are the same compositions, F composed of G, F composed of G, right? The values are different, but it's still the same. G's inside, F is on the outside. So when it asks you to create a new equation, I don't want those. Yeah, come over there. I was like, if it's asking you to create a new equation, what it's saying is if I have F composed of any value at G of X, what could I do? Well, what you're doing is you're substituting the entire G of X. And what does G of X equal? So in F, you're plugging in, all of your x's are gonna become 2x plus 3. So every x is gonna become 2x plus 3. This. So instead of just an x, it's now 2x plus 3. So I'm looking at f of x and it says x squared plus 4x. Where there's an x, I'm going to write 2x plus 3. Do we see that? So we're going to have 2x plus 3 squared plus 4 times 2x plus 3. And that's replacing the g of x. We're going to. We're using f of x is right here.
Oh, wait, so you just combine.
We're creating a whole new equation. You're combining them. You're not using it, you're combining them. You can't have one without the other in a composition.
Oh, okay, I get it.
So here it says f composed of g, right? So if I have multiple things that I'm solving over and over, instead of plugging it into one, instead of doing input, output, I can create one big equation that I just input in, and that's my output.
You have the equation. Wait, oh, you have to together. And then you plug E and F in for F, right?
You plug it in, x in, 2x plus 3 is now replacing the x in this one. Yes. Okay, so this is now your new equation. To evaluate this new equation, you're going to simplify it. If I have something squared, what does that mean I have? 2 of them. So this is actually 2x plus 3 times 2x plus 3. And this is going to be distribute. What's 4 times 2x? And 4 times 3? 12. Yeah.
This is.
Okay.
This makes it a little bit more confusing. I like the other way better.
But if it asks you to create the new equation, you have to be comfortable creating the new equation. It's not going to always be simple. Okay, so now I'm going to distribute. How do we distribute? So we have 2x. Guys, I know y'all are getting frustrated, and if it's not coming easy, you want to start doing other things. That's not how you learn. If you shut off and get mad and get off task every single time something gets hard, you're going to be doing a lot of off taskness your whole life. Persevere, suck it up, pay attention. It's not going to get any easier by shutting off and doing something else. That's going to lead to you failing this class. You have these skills that are in you. This is a buildup of all your skills. Right now, all we're doing is multiplying. That's all I'm asking you. I asked, what is 2x times 2x? 4x what? Square. That is all I'm asking you right now.
Oh, wait.
Because there's 2x, 2 of them.
What is 2x times 3? What is 3 times 2x? And what is 3 times 3? And then the final step is to combine like terms. So what is 4x squared? Well, it has no friends. But I have 6x and 6x and 8x. What does that make? 20x. So now I have 20x. And then I have 9 and 12 makes 21. So this is your composed equation. That is the composition of f composed of g of x.
Wait, so we just simplify it as much as we can.
You simplify, you can't simplify no more.
So we can't simplify no more.
There's no more like terms. There's nothing else I can combine. That is it.
What do you combine the 4x2 and 20x?
Do they have the same variables?
Wait, can't you just square it though?
Yeah. Yeah.
No, that's it. There's no other combining. There's no more like terms. You cannot combine.
If there's another x2,
Where did that?
like if it was 20x2, then.
If it was 20x squared, then I would combine. But there are no more like terms. What did y'all do in Algebra 1?
Wait, what would it be if you did?
I think you
Would it be x4?
There's nothing else.
Oh, yeah.
There's nothing else. You cannot combine. Their terms are all different. All right, so I will come back to you, but we don't have time for your hypotheticals, okay? So now that I have this, when I'm evaluating, all I'm doing is worrying about the X. So here you have X is 2. So I'm taking my combined function and everywhere that there's an X, I'm plugging in a 2. So this becomes 4 times 2 squared plus 20 times 2 plus 21.
Oh.
So then this gives me 4 times 4 plus 80 plus 40. I don't know where I got 80 from. All I did was multiply. 2 squared. And then 4 times 4 is 16 plus 61. Because 40 plus 21 is what? 61. And then what's your final output? 77.
Oh, so, okay. I got it right, but I did it the other way.
Yes, I said, remember this? There was an option A and an option B.
Okay. 'Cause, okay.
Okay?
Either way, my answer would have been right. I ain't tripping.
Yes, so we're gonna, the exit ticket, you're gonna end up turning in, but I don't want it now because it's for the next 6 weeks. So you're gonna hold on to your exit ticket and then I will tell you when to turn it in, okay?
I'm already
But hold on to your exit ticket because I do not want anything for the next 6 weeks now. Okay?
Okay, so for the bottom one, wait, so are we doing these like in our own way, or do you want like 2 of these?
Either way,
Okay. Yeah, I'm finished.
all right, so really quick, if you're gonna do, it's 4, 2.5 squared plus 20 times 2.5 plus 21. That's gonna give us 4 times 6.25 plus 50 plus 21. That's gonna give us 25 plus 71, which is gonna give us 96 as our final output. Okay. All right, so you do your exit ticket. This is gonna be for a grade, but it's for the next 6 weeks, okay? So hold on to it until I ask for it. Got it?
Got you.
All right.